my 6-minute talk on a thermodynamics topic, I picked the triple point. So, thank you. So at this point in engineering, we should all be pretty familiar with what the pressure and temperature phase diagrams are. And all the triple point is the specific pressure and temperature for a pure substance to be in thermodynamic equilibrium in its liquid, solid, and gas phase. And it's where the sublimation line, the evaporation line, and the fusion or melting line all meet and intersect. And I would like to point out that for most pure substances, they have a phase diagram that looks like the solid blue lines, where they have a fusion or melting line that's positively sloped and goes to the right. But for water, antimony, and bismuth, these three substances have a fusion or melting line that goes to the left. And the reason that happens is because they have a solid crystal phase. So when they crystallize and go into that lattice structure, their atoms are a little further apart, and so their solid phase becomes less dense than their liquid phase. And the reason that that's cool for a phase diagram is that you can actually melt those substances just by adding pressure instead of adding any heat and increasing the temperature. And I wanted to show you guys a quick video of the triple point happening. So the triple point for water is around 0.01 degrees Celsius, and the pressure is 611.5 pascals, which is about 6% of our atmospheric pressure. So this has to happen in a vacuum. And when you lower the pressure in this beaker, you also are lowering the temperature required for the water to boil, so that's why we saw it boiling earlier. And as you continue to decrease the pressure and temperature, you'll see that the water starts to solidify here. And as the pressure and temperatures continue to decrease, you start to see little gas bubbles forming as well. So at this point, the water is considered to be at its triple point. However, it's not the true triple point because the amount of water that's in the liquid and the solid and the gas phase isn't really in equilibrium. It's constantly changing in the beaker. And in some videos I saw, not this one, they actually allowed the gas bubbles to pop, like the solid phase popped up, and from the gas bubbles pushing it, and then it kind of all landed down in the beaker again and completely liquefied, so you can see this process kind of happen repetitively. Yep. So the main application of the triple point is that it's used in a triple point cell to calibrate and maintain precision thermometers. So the triple point cell is basically a gas pressure vessel, and it's got a bit of water on the inside, and it's got a well in which you insert things. And to get an accurate reading, the water at the inside has to be of a very specific purity and isotopic composition. And that purity is, I believe, 99.999% pure, so very, very finicky. And you can get a reading from the triple point cells of 0.01 degrees Celsius, which is the triple point of water, and with the astoundingly low uncertainty of 0.0001 millikelvins. So that's why we use the triple point for that, because you get a very low uncertainty with the readings. And the way that it works is that you add some alcohol or dry ice into the well, which starts to freeze the water and forms a mantle, which is what we call the ice in it. And then once enough ice has formed, you insert a room temperature rod into the well, which acts to add a little heat back into the system. And it basically creates a liquid layer in between the well and in the mantle. And once you remove the room temperature rod, you basically have water at the triple point because you've got a little bit of gaseous water vapor at the top, you've got that ice mantle, and you have the layer of liquid water in between the mantle and the well, and also on the outside of the mantle, in between the wall of the pressure vessel. And then after you have the triple point cell at the triple point, you basically put it into a temperature stabilizing bath for a period of 10 days. And over that 10 days, it's basically making sure that it's stabilized, you can get an accurate reading, and it's allowing some of the internal pressure in the ice to be released. And then after that, you use the platinum resistance thermometer in the well to measure the temperature. And platinum is a metal that's resistance is temperature dependent. So when you use the platinum resistance thermometer to measure the voltage to get a steady current, you're basically measuring the temperature there. And so that's how the triple point cell is used to get an accurate reading and maintain and calibrate those thermometers. And I also wanted to share just some fun facts that I found while I was researching this. Well, I thought they were fun. We'll see if you guys think the same. But the first fun fact I found is that not every substance has a triple point. Helium is unique in that it doesn't really have a solid phase that intersects with its liquid and gas phase. It is actually a superfluid all the way down the pressure and temperature diagram. So it does have a lambda point that is right here. And that's probably the closest thing it has to a triple point. But there's no true triple point where it's solid, liquid, and gas phases all occur at once. Instead, you have that superfluid, normal fluid, and gas. Another fun fact that I found is that the triple point of water could theoretically occur on Mars. Since they have a very thin atmosphere, it's around that 611.5 pascals needed for the triple point. And its temperature is also low enough for the triple point of water to be reached. However, it's kind of unlikely this would happen because, as we saw in the beginning of that video, most of the liquid water on Mars would kind of immediately vaporize instead of staying a liquid just because of the really low pressure. But NASA has looked into certain points like the Hellas Basin where that pressure is just low enough for it to be liquid, where the triple point could theoretically occur. But even like a change in the wind or the sun coming out could affect that. So it'd be finicky, but I like that it's at least theoretically possible on one planet. And then the other fun fact I found is that the triple point of water is actually how we define the absolute zero for the Kelvin scale, which I never knew, but that's where that comes from. So that's all the information I had. These were my sources, and if you guys have any questions, I'd be happy to answer them.
6-9.